Hello, everyone, and welcome back to another session of the podcast Deep Dives. Today, we will be talking about XCM integration and testing, and this one, it's itself um, just another episode of this series of XCM deep dives that we have been doing. Our agenda will be bringing a little bit of a high level context about integrations of different parts using XCM, then present different scenarios, covering some testing and some final demo, right? Um, as I mentioned, we have done four previous sessions covering XCM, so by this point we should have a pretty decent understanding of what XCM is used for, what are all the components, how is it meant to be used, right? And today we will be focusing a little bit of a more hands-on part, some scenarios that patching teams deal with, whenever they are um well operating servicing their patchings in Polkadot ecosystem, right? So let's go. Let's get started. Um, I want to just do a quick mention here, this line: with great intercommunication comes great responsibility. Um, XCM opens a door of exchanging these messages, right? Through a transport layer between different blockchains, between different parachains in a secure manner, a trustless manner. And that's very powerful, and it's groundbreaking, right? But also these integrations, these parachains need to be able to have the proper configuration, have the proper setup, be um just constant about that they are certain messages that are arriving to the good destinations and are executed and are the outcomes are basically what they are meant to be, right? So why I'm saying this and why I'm presenting this session in this way is because we have here a little scenario that could be well, just whatever two patterns that are running live at this very moment. They are exchanging messages in a concrete version through a transport layer, right? I don't want to start in a lot of details. I don't want to go into a lot of details, but more or less, okay, let's say that they're using XCM v2 for encoding their messages. They are writing their messages with this language XCM version 2, and they're exchanging messages, right? But before arriving to this point, which is at this point in time in the ecosystem, expected to happen, right? um there's some previous steps, these patterns have to have done something to be able to exchange these messages, right? um from the very point of view of the exchange communication, they need to go through this version discovery process, right? Because as we know, after four sessions of XCM deep dives, XCM is a version specification, it's a version language, right? So you don't want to end up encoding messages with the wrong version and then sending them to a destination that can't understand what you are sending to them. So how does this look like, right? At some point, right, they will have to start the very first message exchange will happen between para A and para B here, so that the registries they can store in their storage that para B is okay, it's compatible with this version of XCM, and para A is compatible with this other one, right? So they are aware and they can encode messages properly. The way this works, the way this is basically that um Palette XCM provides some storage. This is frame, this is runtime, right? It's just providing some storage that XCM will benefit from. Um, I have a slide here, like I have like a screen grab. We can see like the source down here, which is like palette XCM, the library, the lib. There's like these two storage items that I want to focus on, right? So every chain will store like the supported versions for the chains that is aware of, like that I has been like has tried to communicate it with, or like is exchanging messages with, right? And then there will have like this safe XCM version stored in chain. After the first like message exchange, the runtime will tap into the supported version um, storage item to see if like the version that needs to encode the message with is known to its system or it is not. In case it is not, it will default to the safe XCM version and will encode the message with that. And then we'll deliver the message. We'll put that on the transport layer. That will arrive to destination. Will be like interpreted by the destination party, right? In case like the version is like known, but instead of using the safe XCM version, like we'll use like the one that is stored there. Good. So that's more or less like the steps, right, that make them arrive here. But well, not that long ago, like now, well, it has been like quite some time for like blockchain space-time. XCMV3 was deployed like in Polkadot, right? Like, and some parachains started upgrading. So this also like includes like some complexity for the teams, and in the sense that, well, now there are chains. There will be chains that, right, that will start to um, will start to like upgrade to use XCMV3. Others will upgrade later, right? So there will be like these two versions like coexisting at the same time in the ecosystem. Let's go forward in the slides. Something like that could happen. Like, okay, like Parabi like decides to do a runtime upgrade. That runtime upgrade will like make it like work with XCMV3. So we can have new XCVM instructions that this XCVM now can interpret, now knows what to do with them. There might be like type changes because of this like runtime upgrade. There might be like weight changes. There might be other things, right? And now maybe like when this chain is going to send a message to another parachain, I'll have to have more things into consideration. Not really, but I think you might see what I'm trying to build right here, right? What happens that with these upgrades, like whenever like a new XCM version is rolled out, there are two things that are kept. Well, just I mentioned to the 2D weights in this specific case because when XCMV3 started using like two-dimensional weights instead of like one-dimension weights that XCMV2 was using. So there's like two things that came with the upgrade: support for the previous version, that is XCMV2, and also like some translation of V2 to V3 instructions and messages, right? We can see that here, like there's like a screen grab. I don't want to jump into code right now, but that makes it such that if we run into this scenario where like let's focus on the upper part, right? Para A and Para B, they were communicating with XCMV2 because they were the whole version discovery. Both of them were running with some like runtime versions that were working with XCMV2, and then like Para B like upgrades, and then suddenly it also like can work with XCMV3, right? And can interpret XCMV3 and everything. It's like, okay, what happens? Because we have like a new kind of like upgraded XCVM with more instructions, with more like interesting things, right, running in there. So what happens? Like, should they upgrade? Should not? Like, what? Luckily, after like this first like message exchange and part of like the version discovery, there by default, kind of like by default, is like part of the version discovery process. Para A will subscribe to version changes of Para B, and Para B will subscribe to version changes of Para A. right? So they notify each other whenever like they are um, the versions changes. This way they can upgrade the supported versions um, storage and keep up with everything. Though para B cannot like send messages encoded with XCMV3, like cannot send like XCMV3 to para A, because like para A will not be able to interpret those as it is running like a previous version, right? So they will still keep on communicating with V2. Um, and here, like I want to like now like refocus the conversation into like the lower part of the diagram where para C might arrive after this upgrade of para B into like this picture that we have right now might be interested and say like, hey, now I want to establish like communication with you two, and I want to start like exchanging messages with you two. Like what will happen? Like how that version discovery will look like for para C and para A, para B, and all these like right relations that we have in here. So para C is the runtime version which integrates V3, XCM V3, right? Oh, sorry about that. Okay, back. Sorry about that. So the version discovery will be like pretty straightforward in the sense like same steps, right, for both of them. Para C and para B will start exchanging messages with XCMP3 because both of them can understand it. But para C and para A, right, what will happen in there? Like the version discovery is still like happening through an exchange of XCMs, right? So it's like, how does para C knows what should like that message be encoded with when sending it like out there, if he cannot know like what the other chains are using, right? Well, this is kind of like I want to throw like this question here to and give it closure with there is like well, safe XCM version has this name because of a reason. Is like it will default to that version, right? Whenever like it doesn't know which XCM version to encode something with, and that version should be configured such it is the lower common version between like the all living versions, right, that are running at that moment point in time. So for example, right now that we have like V3 live in Polkadot, and we have parchains like running V3 and some parchains that might be running V2 still, like the proper configuration has to be like V2 because that's what their chains when doing discovery are going to default to, and so they will be able to discover themselves and like start like getting this process going. What happens if we don't? Like if we have like some misconfiguration, if our chain has like V3 as the safe XCM version, right, instead of V2, well, then para C and para A will not be able like to exchange any messages because like para C will be encoding everything with V3 and like like sending those messages for para A there, and para A will receive something that will not be able to decode to interpret because he cannot like understand that version of the language, right? That XCVM will be like, yeah, I don't know what you mean, like I don't know what you want from me. So that's I think that's pretty interesting. It's kind of like might sound easy, but or like pretty straightforward or like obvious, but I think it was like it's something important just to double check that um teams cannot like really like control, right, when other parts are running runtime upgrades whenever they are going to adapt a new version, or but teams like no, like right, they communicate with each other if they are integrating other parts into like the features that runtime will might provide. I don't know, maybe para C wants to voice their opinion on something on para B, or like might want to like integrate like some tokens in a liquidity pool from para A or something like that, right? It's like something that the team has decided to include into the runtime that they are servicing as a platform for the whole ecosystem that they are building on top of it. And well, it's like kind of responsibility, as I started like these slides with, to keep these integrations live, right? And how can we be sure, like, if it's like not always that easy, like, or it might, one might think that, okay, like, but if I don't know when the other party is going to do a runtime upgrade, like, how can I maintain my connections and my, right, and my features like safe and like working and available and everything. So there's like a really nice suite of tools that the community is using now, the whole ecosystem like is using now. We have seen two of them, for example, in these like deep dives already: the XCM simulator and the XCM emulator, that allow us to well, navigate different scenarios in terms of like what the outcome of like certain messages might be. We have Thumbbinet, that if it is not per se like one tool like 100% dedicated like to test XCM execution or like integration of like different parachains of runtimes, like it's it can be like a very good like way of like having the bare bones of our like testing environment, right? Another options like parachains integration tests. This is a tool that Alex will show us like later on in this presentation as well. And uh, chopsticks and end-to-end tests developed by Akala are two different tools. Like end-to-end tests uses chopsticks underneath to work, and it's also like a very neat well, tool that can be used to run tests programmatically on the head of the chain to make sure that, you know, like this scenario that we want to test like is still working in the next block or after a random upgrade or whatever. And we might want to like trigger alarms whenever like a test is not passing, because that might indicate us that, okay, like something has happened with that runtime that we want to communicate, that we are sending messages to, because like a few blocks ago like it was working and now like something has happened, right? Like tests are failing. What has happened? Maybe they have done a runtime upgrade, maybe something different, right? But I invite everybody who is like watching this to like really dive into these tools. Sadly, I couldn't like do it here because like this will get like super extend. And Alex, right after me, it's covering like a few of them already. But I believe like it's, I mean, they provide the means, right? They provide the means. At the end of the day, like keeping the integrations live is like a shared effort between like the parting teams. Everybody's like, it's like a win-win situation. Everybody's like benefit by taking care that everything is working fine. And so far, like the runtime migrations are always like provided, or we have like this like translations, like helpers for keeping like at least like always like two versions working at the same time, right? Um. So yeah, this, after these words or navigating this scenario, I would like just to pass it to my colleague Alex, which will walk us through some like nice testing and some of these tools. All yours, Alex.
Yeah, I see I'm live now. So yeah, thank you, Alejandro. So as he said, now we are gonna play a bit around with some of these tools that Alejandro just mentioned. As he said, there has been already 4 previous deep dives with XCM. So if you wanna have more theory, I recommend you to go there, because we talk about the XCM overview, we talk specifically about XCM v3 with demos, we talk about the config and simulator and emulator. And in this one, what we want to do is get the hands dirty and play a bit with the simulator to test different instructions and to see how to mess up with the code in an XCM playground, and then to how to test or how to test our XCMs before go to production to do integrations and end-to-end tests. So first of all, and I promise I only have like 2 or 3 slides about theory, and we'll go into the code. But first of all, to test XCM, what that means. So to test XCM, we have to take into consideration three different aspects. First, that make sure that the message works properly. So according to the XCM spec, that have the proper order and that everything about the message is right. Secondly, we have to be sure that the configuration, the configuration is as expected, as we expect, or configuration of our chain, and that our instructions are gonna work in the configuration of the destination parachain where we are gonna send the XCM message. And finally, the end-to-end. That's not trivial at all because as Alejandro say, you have your chain and you want to communicate with another chain that can have a runtime upgrade, that can change something small in the configuration file, that can break all your XCM instruction. So that's not easy, but we want to make sure, we want to do end-to-end tests to make sure that our flow works in an environment that is as similar as to production as possible. So we want to try to emulate all these chains. So what we're gonna do now is go into some use cases to show some tests and to experiment with it. First of all, and just to explain, there's different options to do a transfer, to do an asset transfer or an NFT transfer. One is a teleport, when the parachain A trusts the parachain B and the parachain B trusts the parachain so they can do a teleport. That's a kind of transfer that where you need trust between the two parachains. And secondly, we have like this reserve bake transfer that involves parachain A doesn't really need to trust parachain B, and parachain B doesn't have to trust parachain A, but they have to trust a third party. That's very used in the Polkadot ecosystem because that can escalate very well. So we can add here parachain C, parachain D, that they don't have to trust each other; they just have to trust one parachain. So in that case, I put here asset hub that is used in Polkadot as a reserve. Is used to do this kind of transfers with assets. We'll have a deep session to go more in deep into what Asset Hub is. But I just wanted to present these two scenarios to see now for you to understand and go into the code now. So as promised, now we're gonna play around with the code. I create here an XCM playground repo that is in my GitHub if you wanna download and fork and play with. But basically, that's coming most of the setup and everything. That the idea is coming from the XCM documentation. That is very good work that the guys from XCM have done. So it goes through all the documentation. Bruno talked about that in the previous deep learning session. But specifically, if you go into the GitHub repo, there is a folder that is called examples, where you have a lot of different 10 different use cases of XCM with explanation. So basically, what I did in this playground that we are gonna go through is take some of the setup, the configuration from here, take some use case and modify in order to get what we want to get for this session. So yeah, let's take a look to some example. So the first example, first better, let's take a look in what's the setup here. So for now, we are gonna use the XCM simulator that allows us to have some kind of playground. So we have like different mock runtimes for a relay chain. For one parachain, that's the runtime mockup for the relay chain. When we have like a frame system, we have pallet balance, we have the pallet uniques for the NFTs transfer. Then we have another for a parachain, and then we have another that for a parachain, foreign parachain that we will see later that have some different configuration than the parachain runtime. So now using the XCM simulator, we are going to set up a test network. So we declare a parachain A that is going to have the parachain runtime that mentioned. We declare a parachain B that is going to have this specific foreign parachain runtime. Then we have another parachain C that has the normal parachain runtime, and then we have the relay chain that has the relay chain runtime. And then we declare, we use these macros that are in the XCM simulator, and we can declare our test network that is basically a relay chain with three different parachains. We have some different methods, some we are gonna see now later, but another thing I wanna mention is, so here we have the Genesis config for the parachain where we populate some of the accounts that we are gonna use for the testing, some of the assets we are gonna create that already exist, the same for the foreign parachain runtime, and the same for the relay chain. So after half of the setup, we are gonna do actually some test some scenarios. So the first scenario I wanna test is when a parachain A wants to mint an NFT on the relay chain. So here the parachain A is gonna send two transact instructions to the relay chain. The first one to create an NFT collection, and the first one has to mint an NFT. Just basic code here. So here we create first the call, the runtime call, calling the relay chain palette Unix with the collection that we want to create. The same for the mint. We mock here some weight estimations because we need weights to create this. We need to pay some weights to create the collection and to mint the NFT in the relay chain. And then here, that's the interesting part that we want to see. We create our XCM instruction. So first we create the collection doing a transact of the call that we previously generated, and then we mint the token. And at the end, so that's very useful for our unit tested, so we can check that we have called the send XCM okay in the parachain in our parachain system. And we can check that in the relay chain, the collection has been created, and the NFT has been minted, and it has been created to our account. So we can go now and try to run that to see if this test is working. So we go to the mint NFT, and here we have the instruction in the README, I have the instruction where we can run just this specific test instead of run all the tests. So we run the test and everything is okay. We are checking that in the relay, so the collection and the NFT is executed. The good part of the simulator is like it's an amazing playground. So here we can play. So we can now go to the relay chain, for example, when we specify all the genesis. So we populate an account with different balances. So we can take this parachain sovereign account of the parachain 1, and we populate with balance. So we comment this line. Now the test is gonna fail. And the test is gonna fail because we don't have weight in our account to create the collection and mint the collection in the relay chain. We wait a bit to see that it fails. Yeah, that was a silly change. Was just comment that, but I wanted just to prove you that if you are you can have like different scenarios testing. You can test what happens when you don't have fees. You can test what happens when you have fees. You can test what happens when you create when you have in your Genesis, when you have in the relay chain an asset that doesn't exist. You can test all different scenarios here with your instructions. Okay, so let's take a look at another scenario. Let's do a transfer NFT. So here we talk about how you can do a transfer with a reverse back transfer. So we are gonna try do now a second part of the NFT transfer. You can see the whole flow in the XCM V3 deep dive session where Hector did an amazing demo where was in the high level using Polkadot.js, explaining all the instruction that was using to do all this flow. And this, for example, is a useful flow. So he was creating a scenario where you have a parachain And there is another where you have NFTs, and there is another parachain where it has like a DeFi protocol, and you want to use this DeFi as a collateral in that other parachain. So in that part of the code, you are gonna just check the last part where the relay chain transfer an NFT into a parachain sovereign account, and then it mints this derivate NFT into the parachain B in this case. And the parachain B, if you remember when we saw the setup here, the parachain B has a different configuration that we have configured, different than the parachain A. If we go to see the code, the difference here is the palette uniques. So the palette uniques is the NFTs palette. We have made some changes with the normal configuration of the palette uniques. Palette uniques usually have a collection ID and item ID that are U32. So a collection ID is one, and the item ID of this collection ID one can be a number 70. Here we are changing that, and we are using some XCM primitives, multi-location, and asset instance. That means that we are pointing that the collection ID here is pointing into using the multi-location is pointing into another chain. So it's not a local NFTs with a normal collection ID. It's been pointing to an NFT of another chain. And let's take a look that into the code basically is doing. So first one, we have like a pre-test where we create this NFT on the relay chain. We just check that that's okay. We can have the search here. And then we are gonna create the collection in the parachain, specifying this multi-location here. So we are pointing to the collection ID of the parent, which is of the relay chain in the parachain B. We are doing a check here that if there is a owner of this new ID, and we can see that is none, so that's gonna work. And then we are gonna execute actually the XCM function that what it's gonna do is transfer the NFT in the relay chain to an account of the relay chain that is controlled by the parachain B, and then it's gonna mint a derivative NFT in the parachain B. That's what we do here in the assert equal on the parachain B and the assert equal in the relay chain. So yeah, let's run that. Transfer NFT. Readme. So we just run one test instead of run all tests. Okay, so the test work, and now I encourage you to go if you wanna understand more in deep XCM. You can come here to the XCM config and just play around with that. So you can change things to see what happened in the instruction that we know it works if we change something in the config file. So in that scenario, you can test different configs of different parachains and see what's happening with your instruction. So for example, here we are gonna be touching the asset transactor. In the second deep dive about XCMs, Bernardo went into every one of these config parameters more in depth, so you can take a look into that if you wanna go in theory about what that means, what every of these parameters means. Now we are gonna just try to mess around. So we see that this asset transactor does is specify how to withdraw and deposit an asset. This has a local Unix transactor. What it has is like a non-fungible adapter, which makes our configuration to understand how to work with non-fungible tokens. So if we delete this line, just feel free to go and play around with that. So you break the code, you see then what's happening, why now the test is not working, why it's working. So if we delete that, we will see that the test is gonna fail, and that's because our configuration is not specifying how to work with non-fungible tokens. That's with the non-fungible adapter. Another interesting thing about here, you notice probably that I'm using the palette uniques. If you are following Polkadot, you know that Polkadot now it has like a new NFT palette, NFT2, but it doesn't exist an adapter yet. It's something that is ongoing. There is a pull request already open with implements these non-fungible version 2 adapters. So you want to play with that too, you can go into this pull request and take the implementation of this non-fungible adapter and play with it in your code. So instead of using the palette uniques, you can be using the palette NFTs. Okay, and finally, let's go to another test, teleport. So we talk here about what a teleport is. It's basically just teleport one asset from one parachain directly to another parachain without the need of a reserve parachain. The code here, well, is doing this different instruction, but what I want to point with this test is how to play with the config again, how to make it fail and how to debug why it's failing and to understand why it's failing and understanding more better the XCM. So here in the teleport, let's run only the teleport now, cargo test teleport. The code is gonna work. You see that there is some comments here. Now we are gonna see what these comments mean. Okay, so the code works. So now we can go to the relay chain configuration again to see, and we'll focus now in the barrier. The barrier is the specification to whether to execute the XCM at all. So it's kind of a firewall to see how if we have to execute or XCMs that are coming from another chain in our chain. So here we have the barrier that it has this specification: allow unpaid execution from everything, which you can guess that means that we are allowing all the XCM instructions without need to pay any fees. If we comment that line and we put another specification of barrier that doesn't have this allow unpaid execution that we are forcing to pay fees, and we run the test again, we're gonna see that now fails. Okay, we're gonna see that now fails. It fails in the line 54. It says that this asset that we have, like in the relay chain, we have like the new withdraw amount is not. So that means that the XCM instruction has not been executed. I'm sure you know that is because of the we have to pay fees now, and we have an unpaid execution, so we are not paying fees. But if we want to debug that, because we are just playing around and messing with the config and we don't know what that happens, we have this line, speed tracing. What it's going to do is just put all the logs that under the hood happen. So all the XCM logs that happen under the hood. So we execute the test again, and now we'll see a lot of logs here. Okay, so we see a lot of logs like clear version, get version, all the things. So we try to find the error, and we have to see here. Probably you won't see because it's very small, but it says that the barrier blocked the execution. So that means that the thing that we have changed is blocking the execution. So that's why our test is failing. That's useful to play around, but it's useful also to have unit tests and to see what's happening in different scenarios. So now we assume so we can change and we can pay fees for that XCM transaction. So we comment the unpaid execution, and we use this instruction by execution that what it's going to do is buy the fees necessary to execute this XCM. We estimate fees. We have this mock function that help us to give a number to estimate the fees. So we uncomment everything here. We uncomment what's expected too, because now we have to subtract the fees too. It's not going to be only the withdraw amount. We uncomment the by execution. And now we are paying fees for that XCM call, and now it's gonna work. Okay. And yeah, so now we have like another scenario that is log asset because it's something that was introduced in XCM v3. I just gonna go very quick here because I really wanna show you the integrations tests that I think are very useful. But we have here the log that comes from the XCM docs examples. So it's doing this scenario. It's a test that is doing from a parachain. It's locking an asset in the relay chain and is notifying the parachain B, is putting parachain B as the one that can unlock this asset. And then in the example, we have like the second part when the parachain A requests the parachain B to unlock the asset. And the parachain B has to execute this instruction to unlock the asset. Yeah, you can see the code here, and you can play with it. As I say, the XCM simulator is amazing to understand, to play with and understand all the XCM instructions, because you can mess around with the instructions, you can mess around with the config, but it's also useful to have unit tests and to have all your instructions tested. But that's not enough, and we are gonna check that the second part, that is a testing demo, so integration test demo. For the integration test demo, I'm gonna check here. We are gonna see two of the tools that Alejandro mentioned at the beginning of this deep dive. One is the parachain integration test. The other is ZombieNet. That, as he says, ZombieNet is not specifically it's a tool that is not specifically to test XCM, but it allows us to set up the whole environment, like set up a relay chain with different parachains, with channels open and everything. I'm sure if you have been following us in these deep sessions, you've been seeing ZombieNet used a lot in all the demos that we've been doing, because it's very useful. And I'm sure in the future we're gonna have a deep dive, like more specifically on for ZombieNet. And then we have this parachain integration test that is also very useful to test the integration between different consensus systems. What it does under the hood, so we specify in a YAML file, we specify different tests, and what it does under the hood when we execute it is convert all these to Mocha tests with child assertions and just run all these tests that we can specify. Yeah, we have here under the examples, it says that it works with ZombieNet. We are gonna run both separately, but it can run with ZombieNet directly using this tool. Here it says how to install it, and here the different options that we have. We are gonna use this option, the mode that is gonna just run the test, because we are gonna run the ZombieNet separate, but you can run ZombieNet too and then test everything with the same tool. And now we are gonna see specifically how a YAML with test looks, but more or less it has this different separation. First, we have the settings. When we declare all the changes, when we set the variables that we are gonna use in the file, and we have some other variables. And then we have the real test. The test looks like something like that, where we describe what we are gonna test, and then we really check that the output is the expected. So yeah, here we have the integration test. So let's see this .tom file, XCM playground.tom. That's to run the zombie.net. And what we are gonna use here, what we're gonna run here is we're gonna run a relay chain. So for that we need the Polkadot binary. Then we are gonna run a parachain with ID 1000 that we'll call state mine. So for that we'll need another binary Polkadot parachain, and we are gonna run another parachain that is the one that we are gonna use to do the interaction with the different things, the different chains. That is Trappist. Trappist. I'm sure if you are following again, if you are following these deep dives, you already know what Trappist is. Trappist is a parachain that is running in Rococo and is kind of what in delivery service team in Parity we use to experiment with XCM to test the latest news, the latest technologies from the Polkadot network. And if you go to this repo, it's very cool because it explains how to run it with how to do the playground with ZombieNet. It has some examples of integration tests, so we are gonna see integration tests now, but it has examples here. It has examples of the simulator too. So keep that, give it that a star. I don't have it, and follow this repo. Okay, so now let's run the ZombieNet. So let's set up our chains. So we go here, readme, and we are gonna run ZombieNet, and we are gonna run the XCM playground. What this is gonna do is gonna set up what we have indicated here, the relay chain with 4 different nodes, the parachain 1000 with 2 collators, and the Trappist with 2 collators too. And in the meantime, it's running. Let's take a look in the YAML where we specify the test for the parachains integration test tool. So in this YAML, we see that first, as I say, there is a separation. First, we have the settings when we specify the chains, the relay chain that is going to run in this port locally, the research parachain that is going to run in this port locally, the Trappist parachain that is going to run in this port. We are going to do the test against the local chain that we are just setting up, but here you can run the test against a live network if you want. Then you have some variables that we are going to use, some of the wallets that we are going to use to do the function. And then here we have the code calls that this is a call that we are going to put in an XCM instruction to execute in another chain. In that case, it's the force create. Let's see one example here of the test. So here we are going to execute this. We're going to execute in the relay chain. First of all, we are going to do this. We're going to create a sufficient asset on the research parachain. So we are going to send an XCM from the relay chain to the research parachain to create an asset. So we create a XCM palette. We call the XCM palette send, and here we have the or XCM instructions. So at the end, we are doing a transact with these force create assets. And what we are expecting is that we see that the event pseudo ID, the event pseudo ID is triggered. And then we can query things. So we can query that the palette asset, that the call asset has this argument. That's okay. We do a search, and we can create here the battery of tests that we're gonna test. In this scenario, we are doing a reserve-based transfer. So let's run this. Okay, let's check that we have all our chains running. So it looks like it's okay. So we can go now to Polkadot.js and see, okay, the state mine local is running in the 9910 that we are specifying here. The Trappist local is running too in the 9920. That's our parachain that is running here, okay. And the relay chain, that's running too. Yeah. So now we can execute our test. Okay, we have this function here, this command. What it's gonna do here is we are gonna execute the test specified in this YAML, and it's gonna go one by one to all the instructions. First, connect to the relay, connect to the reserve, blah blah blah. Then it goes through to. For example, here that we have been testing just the just the instruction that we were checking manually right now, it has been okay. So the event has been triggered. That's perfect. So now it's going through all the different tests. It's gonna take a while because it's waiting for the event to trigger. Let's wait to see that it's all okay. But as you can see how powerful is this tool, because now we have the YAML, and now we know that in our scenario with our Trappist parachain, it works with the reserve parachain and it works with the relay chain. But let's say now the reserve parachain does a runtime upgrade. So if we wanna be sure that our instructions to do this reserve transfer works, we have to take the binary from the reserve parachain, put it here, and simply run the zombie net and run this parachain integration test. And if it's working, that's perfect. And if it's not working, that means that we have to change something in the instructions because that runtime upgrade has a breaking change that changes our configuration. So that's extremely useful for testing the integration between the different chains and different parachains. So yeah, we are here. So for now, it's all okay. So the event was received, the reserve assets were registered. So this all looks okay. Let's wait just a bit more. Okay. So all the tests were passing. That's perfect. So again, with that, we are pretty sure that we are sure we can test very easily without a lot of change in configuration. When something changes in another chain, we can run our test and see that everything is still okay. And finally, before go to the Kusama, before go to Polkadot, it is recommended to test on Rococo. Rococo is a test network that is in the Polkadot ecosystem that it aims to be a playground for different parachains to open channels between each other and to test XCM. So there's a tutorial in the doc substrate where it's very easy to go through and to understand how to register a Rococo testnet. If you already have a parachain in Kusama and Polkadot, you can ask for the permanent slot. If you don't, but you are in testing mode and you just want to play around, you can ask for a temporary slot and you will have it. You will be registered in Rococo. And yeah, there is testing already in Rococo. This is a dashboard that where we are measuring all the different XCM function that is being executed in Rococo. So we'll see that in the last month we've been doing, or the community has been testing a lot of the teleport assets there, the reserve transfer assets, execute, send, etc., etc. So that's basically it. I don't know. I think we are more or less on time. So if you have any questions, otherwise, just enjoy Friday.
Yeah, there is that one question there.
Okay,
Is there
perfect.
still a version 1 or only v2 and v3? So version 1 was deprecated as soon as like v3 was rolled out. So my understanding is like there's only like two versions running at the same time, two versions live at the same time. So whenever like v4 eventually like lands, v2 will be like out of the picture. So it gives like kind of like a timely window to everyone to upgrade to the latest features. I don't know, like there was another question, but it was already like answered there in the chat, like asking about the links.
Okay, I cannot share.
Yeah, that was great. Thank you, Roger. So if there's no more questions, I think we can just wish everybody like a nice end of the day, beginning of the day, depending on when or are you watching this, and wrap it up.
Perfect. Thank you.